stuff, I had a radius side of here that rotated, creates a rectangle inside. Now that excuse my rectangle is not straight, but you get the drift, right? So I'm trying to find the biggest area I can create inside of there. So I worked the problem out earlier, but it was a lot of stuff involved. To make it easier, instead of looking at the whole circle, I looked at half of it. Once I figured it out, I just doubled everything up. That's pretty much it. I guess the best explanation I can come up with is right here, that is length x, and right here has a height of square root 16 minus x squared. Yeah, so it don't matter if it's a square or rectangle. If you want to find the area of one, it's basically what we call base times height. The base isn't actually x, though. The base comes way back here and all the way across. So the base is 2x times that. So that's where this came from. See, I have base times height. There's my base, 2x. There's my height, square root 16 minus x squared. Same one that you learned when you was like in kindergarten or wherever you first learned how to do an area of a square or rectangle. All right, so this is where the calculus part comes in. Right here, the word optimize. That's when you find maximum or minimum values. We call that optimization. So when you see that, that's your regular formula. When you see that, that's a derivative. Yeah, so through the derivative, you got to come through this derivative. Derivative is going to give you your pathway to what we call critical numbers. Critical numbers is what locates max and min values, period, point blank. So calculus is not hard. Don't ever believe that, because this is all the calculus that we did right here. Everything else that you see right here is what you learn how to do in algebra, simplifying, combining like terms, all of that stuff, right? So by solving my equation, I got x is equal to 2 square root 2. That's a 2 square root 2. That's a 2 square root 2. So if you add that up, you got 4 square root 2. That's the base. So when I calculate up here, I get the same answer after calculating. I get a 2 square root 2. But remember, I have to have another one down here because I'm only looking at half of it, not the whole thing. And so when I take that into consideration, I have a 2 square root 2 here. I have another one right here that I didn't draw because I'm looking at half of it. But if I double that up, I get a 4 square root 2. So now I have a base here and a height here. I don't know if you remember what the problem asked for. It said find a rectangle that you can inscribe in here. Technically, what we found was not even a rectangle. If you got the same length on the bottom and the height, four-sided figure, all right angles, you're really looking at a square. I like getting that question sometimes, what does that have to do with my life? I don't know. It may not have nothing to do with your life, but it does have applications that can be done in the real world. I'm going to give you an example in 1 sec. I don't know, the good one I can come up with is maybe if you're talking about like building a house or something, you know, you got a plot of land, something circular, but you're trying to squeeze maybe a building in that parameter. So you want to maximize your floor space. You're going to have to optimize that. I want you to Google something. I want you to take a look at the Apple headquarters. Look at that shape. And if you ever find the footage of Steve Jobs talking about it when they was trying to get approvals for that thing to be built, he was talking a lot of calculus. All right, now watch it go. Watch it go. See, it's inscribed inside of the circle. See that area keeps shrinking and growing. It's going to get smaller and smaller and smaller and smaller. And I'm tracking it right here. All right, so I got it on my big Promethean board right now. But see, this right here, this dot right here, this right here, this A that you see moving, that's representing the area. So every time it calculates the area, it keeps climbing to let you know that the area is getting larger. It hits a maximum part, then it's... Yeah, so we finding the maximum area of a rectangle inscribed inside the circle. There it is. I'm tracking it over here. It hits a maximum. Guess when that happened? It hit that maximum right there when the side was length 4 square root 2. So somewhere around here, I'm going up, then I fall back down. So I'm trying to find out that exact moment I hit the top, and it happened right about there. I'm sitting at the maximum, right there. Yeah, all that work that you saw on the board earlier, when I was finding all that stuff, this is literally what it looks like in physical form now. So this is the maximum area, and what I have is a square.